So hello everyone. I'm Sawood from Old Dominion University, and this is today I'll be talking about supporting web archiving via web packaging. This was a position paper we wrote recently for the Escape workshop of Internet Architecture Board, and they were trying to consolidate opinion and about web packaging, its impacts, how the the publishing industry and distributors like search engines and social media and all, where this will shift the power game. And web packaging, as we know, is kind of an evolution from Google's AMP project, but it is more standardized. It's still evolving, not fully supported in any browser. So this, we saw a big opportunity in web packaging for web archiving. And we thought we'll write a position paper and see. However, in its current form, it's not suitable for web archiving. So we suggested some changes, and we'll go through those things in this slide. So to briefly summarize what web packaging is, so there are a few aspects in web packaging. One is bundling, and the other is signing. There is the third aspect, which is loading, which is purely on the client side, basically, how to treat these bundles and how to load them. So that one is an extension of like the fetch API. Now, what bundling is, it allows you to package multiple HTTP request and response entries, which they call exchanges, HTTP exchanges, from more than one origin together in a single bundle and deliver it as a single resource, which can then browser unpack it, load all the resources in a temporary cache, and in the subsequent calls, it can serve from that particular cache. If the resource is not found in the bundle, then it will go on the live side to fetch that. Now, the cool thing about bundling is if the bundle said this resource came from origin A, then the browser will believe it came from origin A. And then there doesn't need to be any rewrite or anything the way it is done in AMP URLs where a site from CNN.com appears to be coming from Google.com, which won't be the case in this case. Now, how trustworthy will that be? If the bundle says it is coming from origin A, do we believe it? It's same as if you were using a proxy and you were using HTTP, your proxy can respond resources on behalf of any origin, anything. It can change it to anything, and you're going to believe it. Now, then they introduced HTTPS to ensure, no one in the middle has seen what's coming on the wire, and you trust that it is coming from the origin you're talking to. So to bring that trust, there is signing that was included. Now, signing is different from encryption because encryption is more like one-to-one, where the client and server meet in time and they negotiate on a shared key, which is then used for encrypting resources. In signing, we trust that the resource indeed is coming from the said origin, but it is in plain text. Anyone can see in its route. So it's more useful for publicly accessible resources, not something where you exchange your credit card information, for example. So going back to web archiving, here is a simple web page that I created last year for Decentralized Web Summit. And this simple HTML page includes two external resources, a style sheet and a logo in link and image tag, respectively. And there are some hyperlinks as well on this page. Now, when we try to archive this, capturing this HTML source is insufficient. So what we do is we try to archive HTTP headers as well as the payload. Now, combined HTTP header and payload give more information at replay time. And also the corresponding HTTP request record that was made to get this response from the server, that is also preserved. And all these things are preserved in a file called WARC file. And WARC files have different record types. So the one that we are illustrating here on the right-hand side is a response type, which is
I hate to interrupt. I think we might not be seeing the right screen.
Oh. Let's see. Do we see now?
Yeah, I think that's better. Yeah.
All right. So let's quickly go back to other slides. So this was the packaging slide. This was the slide where I talk about an HTML page and how illustrated is source code, and in there I highlighted the two resources that were linked. And then now I was talking about WARC records basically. So on the left-hand side, we have HTTP headers and payload that was responsible for that HTML page we just illustrated. And this whole thing is put together in a WARC record. And since it's an HTTP response, we call it HTTP response type of WARC record. And in WARC, what it is like, the same way we have payload, on top of that, we have HTTP headers. We have some extra headers, we call it WARC headers. And this whole thing combined is known as one WARC record, basically. And there are many WARC record types. There is response type, there is request type, there is for info type, and there are some resource type. There are 7 or 8 different types defined in WARC specification. So a WARC file is basically a concatenation of arbitrary number of these records. And then it is indexed outside using the original URI and the date time when it was preserved. And this is how web archives basically serve. So they have these WARC files collected, and they quickly read the data from here, from this, and do some rewriting and serve it. So, so coming back to the crawling process of web archiving, currently the most popular and de facto tool that is being used for any large scale archiving is called Heritrix. That was built by Internet Archive. So there was a research done in 2015 where Phantom.js used to be the well-known headless browser. So what we realized is, like, if we use wget or Heritrix, we miss a lot of resources, things that are part of the deferred representation. They only appear when the web page is properly rendered and some JavaScript is executed. So more resources are being requested. And those things will not be crawled if you were to use wget or some other tools like that. Heritrix did a better job of identifying such resources, but was still not executing JavaScript. It was just finding signatures in JavaScript for resources. So if you were to use something like a headless browser, you would be able to discover more resources, and you'll have a more complete archiving. But the problem was, using Phantom.js, we were able to discover 75% more resources, but it was an order of magnitude slower than Heritrix. So what we believe is, if the web adopts to web packaging and they start using it, and they package their web pages, not the entire web, but a part of it. So for that particular section of the web, crawling will be easier because we'll be downloading one bundle and we'll be getting all the necessary resources for one or more pages that were bundled together. And we'll rely on the server itself that they know better what resources are needed for the pages, and they bundle them properly. And in this case, we'll avoid scraping through the HTML and the CSS and executing JavaScript to find out all the resources, because we assume that the server has done that job for us. And there will be just one request made, and we'll get numerous resources bundled in there. So, so how Web Archives replay, they basically they take the originally archived resource from a WARC file and rewrite all the links in hyper references and everything, so that those links do not point to the live web or to a wrong URL. They always point to an archived version of those resources. So for example, the style.css is now changed to /web/ a 14-digit number followed by the original domain and so on, the whole thing. This is all so that the browser, next time when it is looking for a style.css file, it's not looking for a random style.css file, but it's getting from the web archive itself. And this is called URL rewriting. This is kind of necessary. The problem is when the resources are injected using JavaScript, for a server to identify properly which URLs to rewrite becomes difficult. And for that, there are two tools like a client-side solutions, like you inject JavaScript here, which kind of traps all the traffic and tries to rewrite or reroute those things on the client side itself. And one such solution was something that we published last year or the year before. It's called Reconstructive. And it is used in IP Wayback, our Wayback system that uses IPFS. And it's illustrated in the corner below. It injects a banner and it tries to trap. So in the figure above, what is shown is like there was an image that was supposed to come from external example.net. But the service worker that we installed kind of trapped that request and said, hey, don't go to external. That will be live leakage. We don't want live resources in an archive page. So then it will strategically reroute it to archive and then ask the browser to request from the archive instead. So in this case, rewriting was not needed. It was trapped when the request was being made. Then there is Ilia's proxy-based solution that is being used in oldweb.today, where a web browser is run in a container on a remote server, which is configured to use an archival proxy. So if you see in this screenshot, the page is coming from the original domain inside, but that is actually talking to a proxy. And the proxy is smart enough to realize, you are looking for an archival copy, so I will reroute it to corresponding archive copy. So internally, the proxy is accessing from an archive, but not telling the browser that it's coming from an archive. Now, this is the kind of behavior we'll be able to exhibit if we were to use web packaging, because then we can store bundles or create bundles ourselves in web archives and deliver that, and the browser will believe like this is how the web is or was. So the rewriting part that was showing earlier, here are some peculiar situations where it goes wrong. So first thing is cookie violations, and we have a couple of blog posts about it. And in this case, we were seeing a Twitter page that was a mixture of Portuguese, English, and Urdu languages. So such a page does not exist on the live site, but this is how archives serve you, because there were some cookies in play and they were mixing resources in different languages. And so basically you are seeing a page that never existed. The second thing, origin violation, and this is the situation in CNN.com. If you go to a recent copy, last 2.5 years or something like that, in Internet Archive and try to access those CNN.com landing pages, they'll be blank. And the reason is there is a piece of JavaScript that says, if origin equals CNN.com, then do these things and render the page. And since archive page is served from Internet Archive, so the origin changed. Now that piece of JavaScript if clause will come into way and it will not let anything render. The third is temporal violation. And in that case, basically, because different resources were captured at different time, the weather page tells a different story in the text form, tells a different temperature and condition of the weather. But the satellite imagery does not agree with that, because it was like weeks or days apart from. So the state of the resource was changed by the time it was captured, and was not consistent. The fourth one is live leakage, and we call it zombies. And here, depending on where it was accessed and all, so the second term, when the Barack Obama was going for the second term election, what happened is there was an ad which was live leaked at that time from the live web, and it appeared to be prophesizing the outcome of the first election result, because the ad was recent and the page was in past, basically. So as if somehow this page knew Barack Obama is going to be elected as in the first term. So these kind of situations happen in Web Archive all the time, where you see pages that never existed, and we want to avoid these things. And we think web packaging has potential to deal with these problems. Now, the problem with web packaging right now is they favor recency. So if there is a resource, say cnn.com /logo.png, and if there are multiple copies of that in the browser cache or in bundle, the browser will use the most recent version, and that's the one it will serve. That goes against web archiving. We want particular snapshot in the past, and it does not allow currently that thing. Now, one way to solve that problem is somehow magically, if it has memento time gate support, which is a standard protocol already utilized by different web archives, and it's illustrated in here, that would be cool. But we have a different solution for that, and that is adding a couple of headers. So for example, server tells browser that, hey, unpack this bundle in a cache namespaced by the name I provide. And in this case, it is a string to 2019-07, but it could be any small string or like an opaque string that browser reads that and says, okay, we'll create a cache with that name and unpack all the resources. And then the server also tells exchange loading policy and says bundle only, which means if you do not find resources in this bundle, do not, in this cache, do not look anywhere else. Do not look in any other cache. Do not look live. Just return a network error or ask back for more bundled resources or something like that. Now, this is not something that is supported right now, but this was one proposal that we kind of put forward there. That will solve our archival replay problem. Now, so moving on to the next problem. Right now, archives do not have a way, a technical means to say this content indeed came from said origin and no one modified its original. And here is a story that we blogged about recently. So Joanne Reed, she recently claimed that copies of her blog post in the Internet Archive were modified or hacked or something like that. And because it was like a decade-old captures of her blog post where she posted some homophobic material, and so she was denying the ownership of that. Now, Internet Archive denied it publicly, and they wrote a blog post about it. Again, they did not have a technical mean to prove it, but they basically said it. And that's how they do it when they are summoned or something. There is a someone from the archive goes and as a personnel and tells like, yes, in the court of law, basically, they say, no, this is the situation and all. Now, we want a technical means to prove it so that we don't involve personnel in that. And I think signed exchanges will be great to have in those bundled resources. And that way, we'll be able to prove. Now, the current problem of signed exchanges is it does not last for too long, like hardly for 7 days or something like that. So we have some solutions to make it last longer. And that is basically, some of them involve like, utilizing, so I think I was a little ahead. Okay, so then, so here, we think we can fix that problem using temporal validations of signed exchanges. And temporal validations means, rather than saying this signature is valid or invalid, you say, in a historical context, you say this signature would have been valid if it was checked back in time as reported by the date header and memento date time headers, basically. So we call it temporal validation, and basically the new state will be called temporally valid. Now, if it is not temporally valid, that's fine too. And in order to elongate the signatures, we have some proposition for that. But right now, we can use certificate transparency logs and some other systems that now exist. They were not there in the past. So we have infrastructure to somehow push this forward. Now, with all that, we would also like browsers to have native support for Memento, or at least they acknowledge that the resource that is being seen, whether it is coming from an archive, whether it's coming from a bundle, or a locally captured HTML file or something. In all those cases, we would like browsers to acknowledge that this is an archived resource. And here we have illustrated basically when thing where we use the chip of the address bar to expose more information about the archive web page. So to wrap up, web packaging has a unique opportunity to devise a technology that supports web archiving and provides a much needed capability to verify the integrity of web archived resources. And we are looking for 4 aspects, like with the effective bundled HTTP exchanges, we'll get efficient and coherent crawling. This is not something that we are fighting anymore, because this is more, if bundled resources become a thing, this problem is solved already, basically. It's just a matter of tools catching up and bundling things properly. Now, time gate support or named caches for loading, that will be something that we ask for. And when that is done, we'll have temporally coherent replay. And if we also get temporal validation in signed exchanges, we'll be able to have long-term fixity and non-repudiation support. And if native memento support in browsers lands, we'll have a visual way to communicate that the resource is archived. So thank you so much. In a couple of minutes that we have, I can answer any questions.
So I have a question. So in the web browsers, do we really want to have support in the web browsers for the concept of archives and basically be able to rewind time? Is that the sort of core idea?
Oh, you're talking about this thing?
I think so.
Yes, we do. The reason is because if we are able to communicate this information, some of the tools and controls that we provide in the browser itself, like in the banners and all, they will be surfaced up in the browser itself, in the toolbar. And people will be more acknowledged that the resource that they are seeing is not live. And we do not want live and archived web to be mixed together. That causes more problems than not. And so there is a battle going on. Browsers, we were pushing for this for like decades now. And there is excellent support of Memento in web archives. But we wanted Wikipedia to adopt to that, because they are using their history, using their own mechanism. We wanted it to be used more standardized way. and we wrote add-ons and all, which gone through thorough review process and all, and then finally they decided not to deploy it because they said, hey, browsers don't support it. And when we go back to web browsers and say, hey, please support it, they say, nah, big sites like Wikipedia don't support it. So there is chicken and egg problem here, but we're still fighting. So this will be fantastic, because if we get this bundling support and all, these archive can bundle things, and they can nicely put the entire bundle in, say, IPFS, and it becomes independent of where the resource is being served from. It can move around and then deliver it from anywhere, and then the browser will treat the whole page, not a single resource, but the entire page with all the page requisites, and replay nicely as if it is coming from the. Now, if you are saying this is CNN.com, you need to have some way to say this is not CNN.com now. This was CNN.com as it appeared 10 years ago or something like that, right? And that's where I think the support in web browsers natively will come in handy.
Okay, thank you. So I think we're out of time. So sorry, I started a bit late and left less time for the questions.
Thank you so much
for coming. Thanks. Okay, bye.
Bye.